Welcome to Making and Treating of Steels course, Lecture 27. Today let me emphasize on this particular TTT diagrams in detail, time, temperature, transformations. These are the transformations which occurs. Now let us know more and more about this particular point, that this particular time temperature transformation diagram, this is eutectic temperature line, and this particular green top line is perlite starting. For example, if you take the temperature of around 750 degrees Celsius temperature in an annealing furnace such as muffle furnace, if you keep it for an hour, it starts formation of perlite, and that is conversion of austenite to perlite. And once it starts, when it is going to this particular dotted line, it is combination of the austenite which is at nose and perlite, and when it goes to this much amount of time, completely perlite, no more austenite completely transformed to perlite. And also about the hardness values, if you see at this particular temperature, when you allow it for the long time, it is coarse perlite. The hardness, Rockwell hardness C scale is 15, and at 50% of austenite and 50% perlite, 30. And at starting temperature, this particular, if you see at this particular point, it is fine perlite, it dominates, that is 50% fine perlite, and at this particular line 50% upper bayonet which has hardness values of 40, and this particular phase is alpha plus Fe3C, it means perlite. This is completely, when it crosses this perlite finish, it is above this line completely perlite. Below this line, it is divided into another phase called bayonet. If it is Fe 2.4C, it is called bayonet. If it is alpha plus Fe3C, it is called perlite. Make a note on this particular point. This line is 50% transformation line, and this is upper bayonet. At this particular line, it will be lower bayonet. And when you cross this particular line, nose, around 500 degrees Celsius temperature, below this, it is austenite plus upper bayonet, and when it is coming down, austenite plus lower bayonet. And bayonet starting line and bayonet finishing line below this 500 degrees Celsius temperature. This is metastable austenite. No more, it do not converts into martensite or any other phases, and unless until you go for the fast cooling. And this particular line where martensite starts, when you avoid touching of cooling within the furnace or outside of the furnace, choose for the fast cooling. When it crosses this particular line, martensite starts forming, metastable austenite and martensite introduced. At this particular line, 50% martensite, 50% austenite. Here completely martensite. The martensite hardness is C scale 64, highest hardness. All these particular details experimentally proven with microstructural correlation. Well organized scientific articles and textbooks are there. With as an introductory part, you would have learned about this particular point in physical metallurgy subject to phase transformation. Even then, let me conclude, for this heat treatment subject, this is a main basis for understanding when you choose a temperature. Heat treatment is the playing a parameters with heating and cooling. When you keep a temperature constantly this much, or when you choose this particular cooling media fast and slow, and water, oil and brine solution, how does it occurs? That is why this particular diagram is very important, crucial for this particular e-treatment part. Making iron steel is the first part of the subject. The second part is this. Now I am taking one of the example part of ectectoid reaction. This is around 0.8% of carbon ectectoid reaction as it is shown in the iron carbide diagram. This left side is called as the hypoectectoid steel. Right side it is called hyperectectoid steel. Left side it is combination of austenite plus this alpha, this austenite plus alpha, and this side this austenite plus cementite, ending line cementite, this phase. Initially these phases are there, and in this situation these phases, this is corresponding to this line and this is corresponding to this line. This is eutectic line. Now let us take one part, ectectoid, hypoectectoid, hyper, hypoectectoid steel. When I am asked for construct a time temperature transformation diagram for the hypoectectoid steel, the eutectic temperature is 727. Hypoectectoid steel, the average temperature is 770. 770 it starts. The phase, initial phase was gamma plus alpha, that is T1, and T is eutectic temperature. It is perlite starting temperature. Mostly when you keep at this particular 770 degrees temperature, below this for long time it completely transform to perlite when it touches to this particular finishing line. This is perlite starting, this is perlite finishing. This line, when you maintain this particular line, when you extend this thing around this particular time, it is completely perlite. The gamma plus alpha was initial phase, the final phase was alpha plus cementite, that is perlite, 100% perlite transformed. Now these are the lines for the martensite starting, 50% martensite, 80% martensite nomenclature. Within this particular diagram it is been shown. This N stands for nose of this time temperature transformation diagram. This phase is around this, if you maintain this time, this much time and this much temperature, it remains as a austenite only. When you cross this nose, it starts from perlite, as I explained in the previous diagram. This is hyperectectoid steel. Hyperectectoid steel, the T2 temperature 80 degree Celsius temperature is chosen. Initially it was, that is hyperectectoid steel side, austenite plus cementite. The starting temperature, when you keep this particular 80 degrees temperature, when it reaches to the this much amount of time, perlite or this particular phase starts, alpha plus cementite it is, and when it come to this particular middle, it is slowly going to complete transformation, 50% transformation of perlite. When it go to this much amount of time, it converts into the alpha plus cementite, that is perlite. This is usual nomenclature, and this is austenite, this is the nose of the curve. This is what you need to draw. Even you can draw for the eutectic temperature also. Eutectic temperature, this particular line will be here, that is the alpha phase or gamma phase converted into alpha plus cementite, that is for the eutectoid steel. And you can draw for the, with respect to the varying composition also, at that particular composition what is the alpha percentage cementite, and you can draw this time temperature transformation diagram at any temperature, at any composition of the carbon. From taking iron and iron carbon diagram, it can be constructed. Now give your opinion on the concluding remark of this particular point. The initial phase in hyperheated steel is austenite plus cementite. Starting, when it starts touch to the nose of that particular curve, it is initially austenite plus cementite. When it completely transform after 1 hour, it may convert into the alpha plus cementite, that is perlite. One need to note this particular point. Thank you.